Well, this is Dr. Pedowitz talking to you about some of the basic triangulation skills. And you've already learned from Module 1 about the basic principles of arthroscopy in terms of the setup and how the arthroscope works. Now we're going to move this towards some triangulation. And the things that we want to cover conceptually here include the ability to steady the camera and the arthroscope so that you or your assistant can do work with a steady image, learning how to orient the image relative to space, practicing concepts of telescoping and periscoping. Telescoping means depth in the z-plane, and periscoping is the use of the actual arthroscope. Learning to move in a deliberate way in a linear fashion just with the arthroscope. Everything I just spoke about is with the camera and with the scope. After those skills are learned, then we want to introduce probing with the contralateral hand, whether that's a stationary or a moving target. And of course, we want to do all of these skills with both hands. So first of all, let's understand what we mean by the concepts of image steadiness and centering. This is just the picture from the template that we created before that we're using for meniscus resection. So this is where you'll practice in a later module meniscus. But I want to point out that this image in reality is very, very symmetrical. It's smooth. It's got a line here so that you can imagine this would be the horizontal axis. This would be the vertical axis. And this just gives you a sense of what this looks like in reality. Okay? And in a moment, we're going to change the image, and I'm going to show you what the arthroscopic image looks like of exactly this same piece of paper, and you'll appreciate some of the distortion that the 30-degree scope introduces into your field. This is a module that fits on the workstation, the fast workstation, that it has two elements. One is a paper holding element. Another is a probing task, which we'll practice a little bit later on. And what I've done is I've just taken a card that fits in the face of this and taken one of those paper templates, cut it out, and scotch taped it on to the front of this. And I'm just using this as an example of these concepts of visualization. So we're going to put the clear dome on first, and this is just, again, to help you learn in real space so you can see inside where you're going. In a moment, we're going to change this to the opaque dome. And the value of this is that you can see with your eyes looking directly down, if you want to, the intersection of a probe with the scope, and you can appreciate some of the hand motions, if you wanted to, looking at your eyes, correlating with the motions of the arthroscope. So I'm just going to take that off and switch, for the purposes of demonstration, now to the opaque dome, and come back in with the arthroscope. And I'm coming in with the scope in this case directly straight on to this piece of paper so that we can learn some of these concepts of steadying of the image, etc. So I've taken the piece of paper, and now you can understand what I mean by the horizon. If I rotate my hand with the on the camera, and I'm going to drive in so you can sort of see the camera, the whole housing is moving. My hand is moving. I'll pull out the scope and show you what I mean by this. My hand is moving in this direction. This is changing the orientation on the horizon. So the objective is, whenever you're doing arthroscopy, to keep the horizon under control, because you want to understand in space where you are in reality. So the horizontal line should remain horizontal. That's the concept of image orientation. Image centering, on the other hand, is demonstrated by that dot on the screen. In this case, I want to work as much as I can with the target centered on the screen. That's image centering, because you're most accurate with your arthroscopy tools if the image is in the center, as opposed to if you're trying to work on that dot and it's off here in the screen. So this is the concept of Steadiness, obviously I'm trying to be steady here, I'm not jumping around. Centering, as well as orientation. Now, the next concept to introduce you to is periscoping. Periscoping is the rotation, as you can see, of the light cord, and as you learned in the earlier module, with a 30-degree scope, it's 30-degree offset from the light source coming in. And as I center on that dot, notice the distortion of that image. We saw that before. It should be a perfect dome, but actually on the screen, you get a little bit of parallax, and this is something you have to learn to cope with. But as I rotate my scope, I'm still trying to preserve that dot in the center of the screen. So this is periscoping. Telescoping is where we're moving in the X direction, closer or further away from the image. The further away you are, the more you see, but also the less accuracy, and if there's bleeding in the joint, the more that will disturb your view. So you want to be at the appropriate distance from your target. That's telescoping. Now, in terms of the next principle, it's to learn how to deliberately move in a certain direction. So, for example, in a straight line, using the fast workstation, you might say, center on that horizontal line, and in a deliberate manner, follow that across from left to right on the screen. Or we could talk about doing it in a more complex shape, in a curvilinear manner, follow the arc around and over the top, keeping that in the center of your screen. So this would be deliberate motion, either in a straight line or in a more complex kind of a motion. Now, let's show one more concept here, which is that if I take my scope out of that portal, which was directly on, and now I'm going to mimic, for an example, for a moment, what would happen with a knee arthroscopy portal. You can see that coming at this target with more obliquity, in order to see it in a slightly more accurate way, I'd have to rotate my scope to look back at that dot, keeping it in the center. So I'm looking back at my target. If I were to bring this in and look in the opposite direction, denoted by the triangle on the periphery of my actual round scope image, I've got the triangle at 3 o'clock right now, but in this situation, it's much more difficult to see that piece of paper compared to 30 degrees looking back at the paper. So this would be an example of the challenge with knee arthroscopy, where the camera's coming in through the lateral portal. As part of arthroscopy, you have to learn also how to make measurements, and the arthroscopic probes that we have come in different sizes. This probe happens to be 3 millimeters from the very tip to the outer edge of the shaft. And so you can use the arthroscopy probe as a measuring tool. And I want to just demonstrate for you that the closer you get to the target, the more accurate it is as a measuring device to that space. I'm trying to measure the distance between these lines. If I hold the probe far away from the piece of paper, obviously it's not nearly as accurate. So this is a skill of measuring with a probe. This particular piece of paper also can be used to practice some of those arthroscopic skills. For example, if you bring in a pen or a felt marker or a pencil, you could create your own exercises and, for example, practice and say, I want to draw only in between these lines over here, or color, or use a highlighter. You can be creative with this and don't stray, for example, and draw in that center line, but then draw over here. So these are just ways to use paper, which obviously is inexpensive and infinitely creative, to make your own modules.